Our problem today is this. Two kids pull on a toy wagon. And the wagon has a mass of 7 kilograms, as shown below. What is the net force on the wagon, and what is the wagon's acceleration? If the wagon starts from rest, how far will it move in 3 seconds? So you have to look, you have to determine the net force, figure out what the acceleration is, and then use the kinematics to figure out how far it went. So given I'll just include the picture here in the given. It gives you the two forces that the kids apply. I'll put the mass equals 7.0 kilograms. And then, what else do we know? Oh, that it's going to displace and we want to know what this delta x is going to be at t equals 3 seconds. And what are we trying to find? Well, A, we're trying to find the net force. B, we're trying to find the acceleration. And C, we're trying to find that delta x. So draw what's given around a picture, okay, for these problems to make them much easier. So let's solve. Where should I solve it? I guess I'll do it down here. Well, to find the net force is what I get when I sum all the forces acting on the object. Now, if I look at this object, I've got gravity pulling it down, but I got normal force, you know, a normal force pushing it back up. They're just going to cancel each other out. So we're not going to worry about the vertical direction right now. Just look at the horizontal direction. I've got a 50 Newton force. Remember, these are vectors. These forces are vectors. So if I say this is 50 newtons, what is this?
Negative 20.
It's negative 20 newtons. In other words, they're going to subtract from each other. Now later on, we're going to get to forces that are in 2 dimensions, and we'll have to have sine and cosine and all that kind of thing. But for right now, let's just deal with this. So that's 30 newtons. 30 positive newton. Positive means to the right. So that's my net force. That's my answer for part A, 30 newtons. Now for part B, we also know that the net force equals the mass of the object times acceleration. So the acceleration is just the net force divided by the mass. So that's 30 newtons divided by 7 kilograms. So what is that, 4 point something? 4.3 if you round it off?
Yes.
Meters per second squared. Now somebody, when I was walking around, somebody said, what is Newton divided by kilogram, you know, how do you get meters per second squared out of that? Remember that the definition for a Newton is a kilogram meter per second squared. We could just write, instead of newtons, we could just write, I'm pushing on this with a net force of 30 kilogram meters per second squared. But that's awkward, right? That's awkward to say that every time. So instead of saying kilogram meters per second squared, I say newtons. And you have to remember that a newton is the same thing as a kilogram meter per second squared. It's a combination, it's called a derived unit. Now, kilogram is a fundamental unit. Meter is a fundamental unit. Second is a fundamental unit. A newton is a derived unit. It's composed of fundamental units. And here they are. So when you take this and divide it by kilogram, kilograms cancel and you get meters per second squared. Now for part C, well, now I know the acceleration. Oh, that's what I forgot to put it up here. It says starts from rest. So V naught equals 0. That should be in your given. So I want delta x. So I know the initial velocity, I know the acceleration, and I know the time. So that would be the third kinematic equation. and this is 0. So this is 1/2 my acceleration, which is 4.3 meters per second squared, times my time, which is 3 seconds. Square it. So that's, what is that, about 17 or 18? What do I get? Let's see. Well, let's see. What is 3 squared is 9. 9 divided by 2 is 4.5. 4.5 times 4. What is that? It's more than 16. What is it? Okay, 19.35 meters. Okay, we can leave it there. Oh, whoops, not newtons, meters. We'll just call it 19.4 meters. Okay, is this problem very realistic? I just made it up. Should have used smaller. 19.4 meters. That's over 20 yards. That's across this room at an acceleration of 4.3 meters per second squared. I don't think that's going to work. But, maybe these aren't kids pulling on it. It could be horses pulling on it. That would be more realistic. And they could probably accelerate at that rate. But that's how you solve the problem. So, big picture, you look at the forces acting on the object. You add those forces together to get the net force. You find the acceleration by using Newton's second law. And once you have that acceleration, if it's a constant acceleration, you can use the kinematic equations to solve for displacements or final velocities or whatever. Okay? Any questions? You'll have to do a problem like, that's right, I was going to grade it. Let's see, if this was a 10-point problem, this would probably be, I'd probably say, knowing this would be +1. The net force is something, summing the force would be +1. Getting 30 newtons is +1. Write down F equals ma. This would probably be +1, +1. Showing the work, +1, +1. And then this would be +1, +1, and then this answer is +1. So a total of 10 points. So you notice that the answers are only worth 3 of those 10 points. Showing your work properly is the rest of those points. So make sure you do that. That is all.